All right, ladies and gentlemen, welcome back to the fourth and final video of Java Arrays. As you can see, I have my main class and my pupil class in here. Please make sure that you look in the description for the video for links to these, as these source files have changed slightly for the purpose of the video. What we are going to learn in this particular video is not only how to iterate through the array like we did in the third video, but we're going to also use some of the methods that are inside the pupil class. So we're going to learn a little bit more about the pupil class for each instance in the array. But we're also going to implement some of the methods found in the Java string class. And you can see I have the Java API open here. We're going to use that on some of the objects that we will find inside of the array for this particular lesson. Now, again, the source files for this are linked in the description of the video, and if you need to go back to any of the other previous lessons, those links will also be in that description. Okay, so what we're trying to achieve here is eventually we're going to invoke the toString method found in the pupil class at the end here, as opposed to this message right here, and it will print out, based on the algorithm that we place inside this main class, only the last names, or the toString methods, for the students whose last name ends with the suffix ski, so ski. So in this particular case, if we look visually, we can see this last name here ends in ski, so the toString method for this object would print out. And if we were to look at the toString method for the pupil class, let's go ahead and take a look at the pupil class. And we see the toString method right here. Now, toString is a default method, whether we code it or not, in every object of the Java programming language. So we could call toString on any object. But we've gone ahead and overridden it in this particular code by defining what this specific method does right here. So basically, what we'll end up having is every student's last name that ends with ski, we'll get the message, student's name is first name, last name, ending in ski, and that's it. So that's what we want to have happen in the main class. If we run it right now, just to verify where we're starting at, what will happen is we'll just print out the index 0, which is just a literal string, and then we will concatenate the result of second hour of index 0, so the first element, which is why we get hello world right here, index 0, because literally we want index 0 printed out here, and then we concatenate student name is John Smiskey. So we're by default calling the toString method of that object, which is why it prints out student name is and then John Smiskey. So by default right now, that's what our code does. Now, just to kind of further boost some understanding here, we see we have an array of objects, 1, 2, 3, 4, 5, 6 objects. If I wanted to print out the last element, this sixth element, I would say index 5, because remember, 0, 1, 2, 3, 4, 5 is 6 objects, and run this. And then it will print out hello world, index 0, bro, ski. And we'll see that right here. All right, so let's go ahead and understand the pupil class a little bit before we move on into some other stuff. So if I take a look at the pupil class, I can see that every object created in the pupil class has 2 fields or attributes, first name and last name. First name and last name both happen to be string variables and privates. Now, if you're following this video because you're practicing for the AP exam, note that you must use the keyword private, otherwise you will lose points. Also though, just as a basic fundamental programming understanding, any of your class level variables, anything that your objects are created with automatically, they should be private, because the only way you want to change those or allow those to be changed is through the methods that you define for this class. So we'll go ahead and we'll actually take a look at that. Let's go ahead and take a look at this method right here, set first name. Now, you notice that the student that I printed out last, the last element in the main method, you'll see that it printed out Bro and Ski. Let's say I didn't want Bro to be the first name. The only way I can change that is by invoking the method, because remember, Bro-Ski is a pupil object. The only way I can change that is if I call the set first name method before this prints out, changing that first name. So let's take a look at this first before I actually invoke it in the main method. So set first name requires that the programmer or the user give it a string, and then what happens is first name, which is the attributes or the field level variable, is assigned the value of first. First is the parameter that we pass through here. So let's actually go ahead and use this. Now I want to use it before I print out because I want to be able to see the change. So what I'm going to do is I'm going to refer to the object. So the object is in the second hour array of student objects. It is the 5th index, and I want to call set first name. So I have to put dot set first name. I'll give it a first name. I will call it Jason. So now what I'm doing is I'm saying, hey, this object right here, which is a pupil object, use the set first name, which is found in the pupil class, and I'm going to pass the value Jason to it. So if we take a look, we can see that just by having these objects already created, we can invoke the methods, and you'll see that now it's Jason-Ski instead of Bro-Ski. Okay? So I don't really want this for long term, so you can either delete it or you can comment it out so that you can keep it for later looking. Let's take a look more at the pupil class and understand a little bit more about it. You notice that I skipped over the constructor method here when I was kind of looking at some of these methods. The constructor method is a method that is used specifically for creating new objects of the class. Constructor methods always start with a capital letter. As a matter of fact, they are always called the same thing as the class. So we can have lots of different constructor methods of different types, accepting different parameters and stuff. We're only going to have one in this particular one, but we could have multiple. In this particular case, our constructor method accepts two string variables, f and l. And then once we call this, it assigns to the first name whatever somebody puts in f, and assigns to the last name whatever somebody puts in L. And we already have done this. If we look at our code right here, new pupil, so that's me calling the constructor, John Smiski. So new pupil, John Smiski. John is assigned to the first name because it's the parameter f, and Smiski is L, which is assigned to the last name. So that's how that's working. We can also see that we have some other methods in here. We can set the last name. We can get the first name, so we can ask, hey, what's your first name? And it'll print it out. And we can get the last name, so we can just get the last name if we wanted to. And here's that toString method that we've overridden, which is why we see student name is, and then prints out the first name by getting first name, which is that method that we just looked at, and getting the last name, which is this method right here. So that's why it prints those out. All right, so our next step is we actually want to create what we set out to create, which is an algorithm that allows us to iterate through this array that we already have and finding just the students whose last name ended with the suffix ski. Now I'm going to be honest with you, full disclosure, in the string class found in the Java API, if we look at the string class, there are lots of methods in here already. One of them is, let me find it real quick. One of them is ends with. So we could use that method real quickly. which would allow us to finish this in just a couple seconds. But we want something a little bit different. We want to actually be able to create ours. So yes, the Java string class already has something built in, but we want to be able to practice our ability to take some of the string methods, to take little slices out of a name. So I don't want to just look at all of this. I just want to check these last three here and then validate whether they equal something called ski. So it's kind of a practice for us in order to iterate through this and do it this way. All right, so we will start with, before we start programming, let's just take a look at the challenge and try to break down and understand the algorithm that we're going to try in order to make sure that we have a good plan and that it should work. So again, the challenge is to take each pupil object found in the second hour array in the main class and to see if the last name variable of each one of those objects ends with the suffix ski. So in this particular case, I have this name Binkowski. Well, I can see, and you can see, that the last three letters are ski. But how do we do that? How do our minds actually think like that and then figure that out? Well, what I'm trying to do is figure out how do I tell a computer to do that. So the first thing I need to do is find the length of the string. In this particular case, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have to think to myself, well, if it's greater or equal to 3, the last name, then I know I could find the words SKI because there's 3 letters there. If it's not, then the name's not going to work. So if I've got a 2-letter last name like Wu, W-U, I wouldn't even bother checking it. By default, it's not going to be SKI because it's only 2 letters long. I then try to isolate the last 3 letters. And there's some ways that we can do that using the string class. It's actually called substring, and we'll take a look at that in just one second. So what I'll need to be able to do is I'll need to be able to come up with some way that allows me to go, okay, given any name, first, is it at least 3 letters long? Yes. Okay, great. Then let me go, how long is it? This one's 9. All right, so then if I wanted to take a look at this, 1, 2, 3, I'd have to start here. So the length of the name minus 3, start there, then show me the next 3 letters, SKI, or not SKI, depending on what last name we have there. If it is some variation of SKI, then we will return the Boolean true, which means yes, this is the name, go ahead and print out our message. If it's not SKI, we're going to return false, which means don't print out a message, this isn't an SKI name, we don't need it. So let's go ahead and take a look at the string class to see what some tools are that are available. Okay, so we are in the string class. I went down to the substring method. As a matter of fact, there's 2 substring methods. One only requires 1 index, and the other requires the 2 indexes. The difference between the two, if we look at the documents, is the one that just takes in 1 integer returns a new string that is a substring of the string. So basically that's, we clip a little piece out of the current string and then it returns what's left over. So let's take an example. Unhappy is the string. If we use the substring method and we give it the value 2, which begin index would be 2, the return would be happy. So it takes from 2. Now remember, a string is basically an array of characters. So 0, 1, 2, 3, 4, 5, 6 are the index numbers. So it's 7 elements long, but the index starts at 0. So 2 in this particular case means we will start at 0, 1, 2. Here's where we'll start. So that's why it returns happy. Looking at Harbison, substring 3, 0, 1, 2, and then we start at suffix 3, which is why it returns bison. Now, that looks like that would work for us because, again, all we do is have to find out how long is this name. Let's go back 3 from the end of it and then return what's left over. So that one should work for us. But this one here, let's take a look, requires 2 parameters, begin index and end index. So let's take a look at this. So if we pass the string hamburger here and we call substring with the 2 variables, 4, 8, again, knowing that the strings are basically an array of characters, we've got 0, 1, 2, 3, and we start at 4. So we'd have 4 is what we'd print out, 5, 6, 7, but we will not print out 8 because that's where we want to end it at. That's why it prints out just the word urge. And if we have smiles and we call the substring from 1 to 5, again, we ignore 0, so we'll print 1, 2, 3, 4, but we will not print out 5. Okay, so that's why we just print out mile. So for our particular purposes, this first one looks like it'll work just fine. We could use either one, but this one seems to be a little bit more simple in that we're not trying to pick anything in the middle of a word, we're just trying to look at the end of it. So that should work out perfectly for us. So before we actually start trying to code the whole solution, let's go ahead and take a look at testing small pieces of it. The first thing we need to do is figure out how do we find out how a last name, how long last name is, and just to get the last 3 letters of that last name. So first one we're going to test on is a name that we know will work, which is this one right here, Binkowski. Now Binkowski is the last name of a pupil object found in the second hour array, and it is the 1, 2, 3, 4, 5th object there, which means its index is 4, 0, 1, 2, 3, 4. So what we will do is we're going to first print out the object. So we will say second hour array, and we will print out object 4. If we go ahead and rerun that real quick, we should see a couple messages, hello world, then we should see James Binkowski, and then we would see index 0, student name is Broski. To avoid confusion in the future, I'm just going to go ahead and comment that out, and I'm going to comment out the hello world because I just want the one message now. So I'm able to print out that. What if I just wanted to print out the last name? Well, I have getLastName, which is a method in the pupil class. So all I have to do is refer to an object, which I'm doing here, this object right here, and then print out getLastName. So now if I run this, it prints out just the last name because I'm calling the last name. So now I've got the last name. So now I want to return the substring of the last 3 letters of that string. So let's see if I can then, I've got the object, I've got the last name, now I'm going to invoke on it the method of substring. And in this particular case, if I look at this array or this string here, 0, 1, 2, 3, 4, 5. I want to start at 6, it looks like. 6, 7, 8 would get me. All right, so substring 6. All right, so now if I run that, I see that the printout over here will give me just ski. So I've been able to get that, which is really cool. Now, the problem is if I ran this very same one on, let's say, this 1, 2, 3, 4, 5, 6, 7, 8. This one's only 8 letters long. So let's say I pick that very first element, which would be index 0, and I run the same exact code. We're going to see a little bit different behavior. which is just ki. So not quite right. So we can't just use a magical number here because it's not going to work. All names have different values or different lengths. This is where we have to go back to the string class again, and there is a method in here that is referred to as length right here. So length doesn't require any parameters. We just call length. It returns the length of this string. So let's go ahead, before we get too involved in here, let's comment out this particular thing here, and let's see how length works before we start coding stuff. So I'm going to print out the result of the object's second hour. We'll go the first element in there, so index 0 dot get last name dot length. So now this should print out the length of that last name, because second hour index 0 is this object. Get last name gets just the last name. Length, as we see, returns an integer, so a number, and returns the length of that string. So let's go ahead and see what it returns. It returns the value 8 right there. And again, 1, 2, 3, 4, 5, 6, 7, 8. All right, cool. So it has returned 8. And just to make sure this works pretty easily, let's go back to this next one. The second element in this array, which would be index 1. And that is, we can see, just 3 letters long. So it should return a 3 here if this is working correctly. And there it is. There's our 3. Okay, so now that we've gotten the ability to substring, and we've got the ability to find out how long a name is, let's comment this out, and let's try to put it all together. So I'm going to actually steal this right here, because I'm going to use this as the starting ground here. So again, I have a second hour object at element, the first element, or index 0. I'm getting the last name, and I'm going to start this substring, but I don't want to start the substring in a magic number. I want to be able to get the length of the name, and I want to minus 3 from the length, because no matter how long the name is, if I go back 3, 1, 2, 3, I'll be able to see if it's ski or not. 1, 2, 3. There's only 1 here. 1, 2, 3, right? So I'm working backwards on all of these strings anytime I check them. So inside that substring parameter, we will get the length of the last name. So get last name, or actually we have to refer to the object. So second hour 0, which is the same, dot get last name dot length minus 3. And then we will go ahead and take a look. So what we did is we said, hey, print out for the object in the second hour array at the first element, the last name, a substring of that last name, which starts at that object's length of the last name minus 3. So that's basically what this is doing, is it's taking a look at the object, going 1, 2, 3, okay, check that out, 1, 2, 3, check that out. So now if we run this code and we just look at this first element, we will see that it prints out that the last three letters of that name are indeed SKI. Let's try a different one. Let's try this object right here, 0, 1, 2, 3, found at index 3. So we need to change this index, and we need to change this index. We run it, and we will find out that the last three letters are PPY. All right, so now we have an algorithm, well, not an algorithm, but we have a piece of code that will allow us to take an excerpt of a last name. So now that we know how to do this, we can actually put this in a method in our pupil class in order to continuously run this. So let's go ahead and take a look at that pupil class. If we scroll on down, we know that there is a Java doc that I've already placed in here. And basically it says what the challenge is. We will take the suffix of a name at last name, so we will accept the last name, and then we're going to check the last three letters, and we're going to evaluate whether it is SKI or not. So we've already done a lot of this work. We're just moving it into a method so that we can call it more easily. So we will go ahead and we will create the method header for a new method. It will return a Boolean, so a true or false, much like the Java documentation says. And we will name it getSKI suffix, because it kind of explains what it does within the name. And we will allow to pass to it a parameter referred to as LName, as the Java documentation suggests. And we will give it its opening and closing braces. I'll hit enter a couple times, get some space. All right, first thing we need is a variable in order to basically compare it. So I'm going to call it suffix. It's a string variable, and I'm going to assign to it the value of SKI. And then I'm going to go ahead and run a check. So if the LName of the object, and this is really where all of our work comes from over here. As a matter of fact, I can almost steal this word for word, almost, but not quite, because the second hour array doesn't exist in Pupil. It only exists in main. So a lot of that thought, though, that we put into it will definitely apply here. So if the LName dot substring, so again, we're getting the substring of the last name, dot, not comma. So if the substring of that name, and then what we're going to do is we're going to do it in a way that allows us to go backwards, because substring, remember, needs an index to start at. So I just want to start at the last three letters of the name. So I have to first get the length of LName, and then I have to -3 from it, so that'll let me get the last three letters. So if the last three letters of that name, and then I'm going to need to compare it against SKI. So let's take a look at the string class and find out what method we could use in order to compare that against the value of SKI. Searching through the string class, I found a method named equals ignore case. Now I specifically picked this one. I could have picked some other methods, but I picked this one because it is the most robust solution, which means if somebody messes up, then by printing the last name they accidentally type a capital K or a capital I or something like that, it will still ignore the case of it, but it will still compare the letters to each other. So equals ignore case takes in a string in order to compare it against. All right, so let's go back to our code, and we will use the dot notation, dot equals ignore case. So we're saying, hey, if the last three letters of the LName is equal to, and ignoring the case, uppercase, lowercase, this suffix, let's get the braces for the if, we will return true, which means, hey, that's true. Else, we will return false. All right, so again, just a quick review of what's going on so far is we create a variable named ski, or assign the value ski, its named suffix, and then we say, hey, if LName, which is whatever last names passed through here, substring, and we're taking the substring of the length of the last name minus 3, so hopefully SKI. If it equals suffix, ignore in any case, capital or lowercase, then return true, else return false. So let's go ahead and go back to the main class and let's test this out. So in order to test this out and to avoid a little bit of confusion, I'm going to go ahead and I'm going to comment out what we've done so far. And then I'm going to print out the result of the method that we just created, get ski and get ski suffix, and I'm going to do it on the first object. I expect it to return true because you and I both know that that is ending in ski. So I'm going to look at the second hour array. I'm going to look at this first element, which is 0 index, and we're going to run get ski suffix. All right, so let's see if we have any errors or any problems. All right, I do indeed have an issue. Let's take a look at it. So right here, it says that there is cannot be applied to the given types. It says that there is an issue where we require a string, but there's no arguments found. So let's take a look back. If we remember, when we created get ski suffix, we need to pass to it a string called LName. Well, we did not do that. We just called get ski suffix. So let's say we need second hour element 0 dot get last name. So now we've passed to it the last name of the object found in the second hour array at element 0 or index 0, which again is this one right here. So let's go ahead and run that, and let's see if we've hammered out or if we have new issues. All right, so that time it worked. So it returned the value true because we know Smiski is indeed true. Let's quickly run through two more different variations. Let's run this one right here, which is the index 1. So we will run Sally Mae, and we will run that last name, and we will see that you and I both know that Mae does not end in the suffix of SKI, so that's an issue. Now, for an added twist, we will see that we might have an issue if we try this name right here. So this is the third element found at index 2, so let's go ahead and move that over to 2. And then if we run this, we will see a different output. Okay, so now we have an error, a string index out of bounds exceptions. So basically, we can't do it on this one as is because our pupil class, that method that we create, takes the last name, minuses 3, and then prints it out. Well, in the case of this name, which is B and only B, well, if I take this and I minus 3, I have nowhere to go to. It's out of the index or the array of the last name. I can't go into negative values. So that's an issue, and that's something that we'll need to make sure that we take care of. And let's do that really quick. So what we'll need to do is we'll need to make sure that we check before we run this right here. We'll need to make sure that before we do all this that we check to see if the name is even long enough to validate. So what I'm going to want to do is I'm going to want to put an if up here that encompasses all of this stuff. So let me get some space here because this is the brace that closes the method, and above this if I'm going to create one more if. I'm going to say if the lname, which is the variable that's passed through here through the parameter, if lname dot length is greater than 3, greater than or equal to 3, we should say, brace, and then end brace. So basically what I'm saying is, hey, if the last name is greater than or equal to 3, sure, go ahead and see if the suffix is ski. If it's not, false. Okay, so this if right here encompasses all of that. So I'm going to go ahead and put if 1, if 2, if 2. So I'm commenting these braces real quick. All right, so then after that if statement, I'm going to go ahead, again, I'm inside the method, I'm going to put an else, because if it's not at least 2, then I'm just going to go ahead and return false. All right, so again, just taking a quick look at this, what we're doing is we're saying, hey, if the last name passed in here is 3 letters or longer, let's go ahead and validate to see if it's ski. If it's ski, cool, return it as true. If it is greater than 3 but it's not ski, return false. If it's never 3 or longer, then just return false, because we know automatically it is not ski. So let's go back to our main class and take a look. We're not going to change anything here. We're still going to take a look at this second index, index number 2, which is the third element in here. So we're still going to look at JB. We're going to run that, and we'll see what our output is. False. Good. So now we can check names that are smaller than 3 letters and verify back to the computer that it's false, as opposed to crashing in an error. So now that we validated that we have a method in the pupil class that works, let's now create an algorithm to sort through the array of all of our objects in the second hour array, which are all pupil objects. Let's get their last names and run that suffix, that getSki suffix method on each one of those in the array, so that we can very quickly and easily print out just the names of those particular pupils that end with the last name suffix of ski. First thing I'm going to do is just comment all this stuff out again, get rid of it, and then I'm going to give myself some space up here so that I can try to start off as neat and clean as possible. I'm going to iterate through the array, so I'm going to create a for loop. I'm going to create my integer I, which will be assigned the value of 0, and I will continue to run through this for loop as long as I is less than the length of the second hour array. And I'm going to do what's inside the for loop, and then I will iterate I at the end of each run through. So there's my braces for the for loop. And before I get too fancy, again, I'm just going to go ahead and test things out. So I will do a system.out.println. And I will just print out a message, index is, give it a little space, and then I will just simply print out the value of I. So this is just my testing, hey, am I actually going through all the variables? So let's go ahead and run it real quick. All right, so index is 0, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. Perfect. So I'm iterating through the array. I'll go ahead and I'll leave those messages up just in case I run into any errors in the future. I'll know what index it tripped at. So now what we're going to do is we'll go ahead and we will put a comment here. And that comment is if the pupil object found at I, get suffix, last name of that object, returns true, print toString for that instance. So you don't have to have the comment, but I put it there so I understand what the code's going to do. It won't change how yours actually runs. So what we'll do is we'll go ahead and we'll put in an if here, and we will say if the second hour object found at the index I, just like the comment says. So second hour index I dot get ski suffix, and then we will go ahead and get the last name of that object, second hour found at index I dot get last name. And then we will see if it returns true, because remember, get last name returns true or false. Get a brace here. And then we will simply call out the string method. So we will say second hour I dot to string. And let's go ahead and run that real quick. Okay, so now we have an error. Let's take a look at this. So it's found on line 26, and the error symbol, variable second hour, location class main error, compiler exit 1. So there's some issue with here. Let's take a look at this code. And I take a look real closely. So if second hour, which is the array, I is the element, so it points at a specific object, dot get ski suffix, second hour. So I see right here, I messed up. I have second hour instead of second hour. So now, if I run that, okay, great. So now it's printing out 0, 1, 2, 3, 4, 5. However, I'm not getting this to print out. So something's going amiss with the names, which aren't printing out, but the program runs through it just fine. I can see that it's running through, so there's no errors here. So when I look at this and I see the toString, what's happening, or what isn't happening, is we aren't asking it to literally print out on the screen. So all we need to do is to encase this in a system.out.println. And once we've encased that in there, and we run this, and we take a look, we will see now that we have created a program that iterates through the arrays. So index is 0, student name is John Smiskey. So that one, because of the call to get ski suffix, works. Index is 1, so the index of 1, if we take a look at it, Sally Mae, that doesn't, so it just skips on. 2, JB, not only is it too short, but it definitely isn't a ski, so that skips on. 3, Sam Skippy, even though there's a ski here, because we take the substring of the last 3 letters, it doesn't trip that on, so it goes on. Index 4, which is Binkowski, yes, that is a ski, so it prints it out. And index 5, which is the 6th element in the array, bro ski. Well, ski is only 3 long and it ends in ski, so we print it out. So we have completed the challenge. Make sure that once you have this done, make sure you go ahead and you share me on the Replit so that I can see it and that I can evaluate it. If you are doing this for a grade, if you're just doing this for fun, then you're set.